Hi, my name is Stephen McGee and I'm the author of Toxic Electricity, and we're here today to look into grounding systems. And we have this spark generator here, and this is to simulate some of the problems that may have occurred with David Blaine's Electrified experiment. So we've got the spark generator. This is simulating his Tesla coil. Just to let you know that this is nothing like a Tesla coil. It's far, far milder. This only operates at a few thousand volts. David Blaine's Tesla coils were operating at millions of volts and were orders of magnitude higher in power levels than what this produces. This only produces a spark of a couple of millimeters. So this is a conventional car ignition system, and a little motor that triggers it, and it's connected to a car battery. So what we're going to do is we're going to see what happens with grounding cables, because the theory is that David Blaine had a Faraday suit, and his Faraday suit was connected to a grounding cable, and all of that protected him from electromagnetic radiation emissions. Well, we're developing the theory of Faraday suits and human health, and we're going to test that theory out with this ignition system. So I'm going to turn on this radio. This radio is going to pick up our electromagnetic emissions. As you can see, it's actually tuned in to AM 530, and there's static there, there's no radio station. And it's the video camera. So something to be aware of is that some electronics are really, really noisy, and this video camera is one of those pieces of electronics, and you need to be careful with your exposure to electronic products that are like this one. So let's turn on our spark generator and see what happens. So this is a 12-volt battery, and we need to turn on our ignition system pulsar, which is this simple children's toy motor. So our spark plug should be flashing. And there indeed is the spark. So the area is now filled with electromagnetic pulses, which you can hear on the radio. There's a lot of interference around this equipment. So what I've done is we've got this grounding cable, and to get out of the electromagnetic field of the sparks, we're going to go over to the other side of the house, and we can see that the noise is almost gone on the radio. So in fact, it has actually gone at this point. So we're probably about 20 or 30 feet away from that ignition system. So this is where the cable goes. So I put this piece of foil down. I'm going to look into screening. But let's see if we can pick up on those pulses before we do the screening. So this is the grounding system of that ignition system. So this is the grounding cable. This cable goes to the negative connection on the battery that's powering it. And there's no doubts it's giving off electromagnetic radiation emissions. And it's distance related. So the closer you get to one of these grounding cables that has pulses, electromagnetic pulses going down it, as David Blaine's grounding cable and Faraday suit had, the bigger the emissions get. So there's no doubts that David Blaine's Faraday suit was actually giving off this kind of emission. And it was close enough to biologically couple into his body through air, as we're demonstrating here. So one of the concepts about Faraday cages is you need to stay away from anything that's grounded, that's getting hit by sparks, because the closer you get to them, the more coupling through air takes place. So whenever you're inside a Faraday cage, you probably want to be a few feet away from the edges of it so that you're not being subjected to this coupling effect that occurs on the grounding system. So, the reason why we have foil here is that this is the simulation of the Faraday suit. So, as we can see, it's grounded, and we can clearly hear that the radio is pulsing. One of the things that you can see with the AM radio is that it can be directional in certain fields. And the pulsing will get louder or quieter depending on which direction you turn it in. So all fields have an X, Y and Z direction. But let's see if we can stop the pulsing. Just put the radio in the middle and throw the foil over it. So we have actually stopped the pulsing. So Faraday shielding does work to some extent. But if we lift it up, this is an important concept with Faraday shielding, is that you need to be very, very careful about having gaps in it. So we can see that the gaps in this, if I put my hand there, only maybe like an inch. And if we lift it up, so we've only got a gap of a couple of inches. It's all grounded, but we're picking up pulses. So the thing you'll realize from this demonstration is Faraday shielding is very much a black art. And it's very, very difficult to get right. And the more gaps you have in your shielding, the more likely it is that these pulses are actually getting through to whatever's inside the shield. So the thing that I was concerned about with David Blaine's suit was his helmet and his boots. If you look at the videos of David Blaine, he doesn't have a complete shield over his head, nor does he have a complete shield over his boots. He has these wire cages. These wire cages have gaps in. As you can see, as soon as you start putting gaps in a Faraday cage, the electromagnetic pulses start getting through. So that's Faraday shielding and noisy grounding systems for you. I hope you enjoyed the presentation, and I wish you the very best of help.